This video will show you how to do operations with matrices. There's two essential questions. How do I add and subtract matrices? And second, how do I use scalar multiplication, which I promise sounds a lot more complicated than it actually is. Before we get to that, let's first talk about whether or not a matrix is symmetric. So what symmetric means is it's going to be the same on the left as it is on the right. So what I do is I first start by drawing a diagonal. Well, let's look at matrix K and matrix L. I'm going to draw a diagonal in matrix K and see if my elements are symmetric. So I'm going to look at my elements that are diagonal from each other. So the 2's are equal. The 7's are equal. This is a -5. This is a +5. They are not the same. Matrix K is not symmetric. Matrix L, let's do the same thing. I'm going to draw a diagonal from going from the top left corner to the bottom right corner. And I'm going to look. I've got 7 and 7. Those are the same. -1 and -1. Those are the same. 4 and 4. Those are the same. 8 and 8. Those are the same. -2 and -2. Those are the same. So matrix L is symmetric. Let's look at adding and subtracting. If you're writing this down, here's the most important part. Adding and subtracting matrices can only be added and subtracted if they have the same dimensions. It is really important they have to have the same dimensions. Also, make a note, the resulting matrix will have the same dimensions as the original matrices. So before we get into whether or not you can actually, or how to do it, let's get into whether or not you can do it. So this example at the bottom, we're going to first figure out whether or not you can add and subtract these together. So this is a 2-row by 2-column matrix. Remember identifying it the same way we did in the last video. This is a 2-row by 2-column. These are exactly the same size. You can add those together. Letter B, this has 2 rows and 3 columns. This has 3 rows and 2 columns. Not the same dimensions. You cannot add those together. Letter C, this has 2 rows, 3 columns. This is 2 rows, 2 columns. Not the same dimensions. You cannot subtract them. Same rule as adding. This has 3 rows, 2 columns. So does this matrix. Therefore, you can subtract those together. Again, you have to have exactly the same size to be able to add and subtract matrices together. Let's actually do a problem together. So in this one, we're going to call this one matrix A. We're going to call this one over here matrix B for the sake of our problems. So when we do that, let's look at the element that's in row 1, column 1 of matrix A, which is this 10 right here. Row 1, column 1 of matrix B is 7. I'm going to do 10 plus 7, which is written here. Once I do 10 plus 7, it gives me an answer of 17. It works for any element in the matrix. Let's go to the second row, third column, which is 14. Second row, third column is 10. I'm going to add 14 and 10 together to give me a final answer of 24. You can also do this using the matrix calculator like we talked about in class. So I'm going to type those two matrices in. I'm going to first start by clicking New Matrix. Notice this is a 2-row, 3-column matrix. So I'm going to add a column. And I'm going to type those numbers in. 10, 15, and 3, 13 in the top row, 11, 8, and 14 in the bottom row. Then I click on New Matrix. Matrix B is also a 2 by 3. The elements are 7, 10, and 12 in the top row. In the second row, it's 9, 7, and 10. Now I want to add them together. So I'm going to hit this blue arrow, and I'm going to type in A plus B. And it gives me my answer here, which if I slide the screen over, matches the answer we have right here. Notice if I were to change matrix B to a 2 by 4 matrix, and then I try to add them together, notice I get an error message telling me I can't add matrices with different dimensions. Works the same way if you have subtracting. Speaking of subtracting, it works exactly the same way. You take your elements that are in the same position in each row and each column, and you subtract them together. Be careful when you have negative numbers, because this is like saying 2 minus -1, which is the same thing as 2 change opposite plus 1, which is where the 3 comes from. So be careful with your minus signs. They can be very confusing. Let's get to scalar multiplication. Like I said, scalar multiplication sounds more complicated than it actually is. The way you would have a problem is it would look like this. It would say, find for me 3A. And let's say this was matrix A right here. What I want to do is I want to simply take that 3 that's on the outside and multiply it times everything that's on the inside. It's kind of like doing the distributive property a whole bunch of times. 3 times 3, 3 times 1, 3 times negative 2, 3 times 5, 3 times 6, 3 times negative 3. That's where this matrix comes from in the end. You can also do this by using your Desmos calculator. So let's work that one out. If you hit clear all in your matrix calculator, it'll clear all those out for you. I'm going to type in the matrix that I start with, which in this case is this one over here. Notice the dimensions are a little bit different. It now has 3 rows and 2 columns, 3 and 1 in my top row, negative 2 and 5 in my second row, 6 and negative 3 in my third row. Now I want to calculate what is 3A. And then my answer here will match this answer over here. It takes a while to type those numbers in, and it's probably easier if you just have a problem that asks you what is 3A to just simply multiply 3 times everything on the inside. Where the matrix calculator can come in handy is if you're doing the same problem, the same matrix, but you do it finding 3A and then 4A and then 6A, it's easier than retyping them in to have to use the matrix calculator. It also works really, really well if you have a problem that looks like this, a problem that said, what is 4A minus, 5B? Because let's say you're using these matrices up here, you have to take this matrix A times 4, multiply all these numbers by 4, then take matrix B, multiply all these numbers by 5, but wait, there's more because then you have to subtract them when you're done. So I think using the matrix calculator would make sense for a problem like this. It wouldn't really make sense to do it for a problem like that because you can probably do it faster than you could just typing the numbers in. That is scalar multiplication and adding and subtracting.